How do you classify a convex polygon? This video is for task 6.5. This is the title that should go at the top of your paper. And then a reminder that this is the video title that is written in the left-hand column. Here's a reminder of how your notes should look to take notes from this video. A polygon is a closed plane figure with at least 3 sides that are segments. The sides intersect only at their endpoints and no adjacent sides are collinear. So here's a review of what a convex polygon would look like. Here, notice that it's a closed plane figure with at least 3 sides. So here's one figure with 3, a triangle, and as long as it has 3 sides or more, it is considered a polygon. And we're going to be focusing on convex polygons, not concave ones. These are examples of concave polygons. Notice how they kind of cave in to the polygon here and here. Notice none of these do that. So they're convex polygons. And here are examples of non-polygons. This one is not closed. The segments are crossing. Not all sides are segments. Notice there's a semicircle here for this one. And this polygon is not on one plane. So make sure you take the time to pause the video and write down what a convex polygon is, what a concave polygon is, and what classifies as not being a polygon, but just a shape. Here's a chart that explains the number of sides for a polygon, what the polygon name is, and its interior angle measurement. Go ahead and pause the video, copy down the chart in your notes, and when you're ready to follow along with me, go ahead and resume the video. Okay, I'll assume that you paused the video. So now let's begin. The number of sides can tell us what type of polygon it is. If a polygon has 3 sides, then it's going to be called a triangle. And each interior angle measure is going to be 60 degrees. If the number of sides are 4, it's going to be a quadrilateral, which we had just discussed the relationship between different types of quadrilaterals. And the interior angle measurement would be 90 degrees. A 5-sided polygon would be a pentagon, and so on and so forth. For the different number of sides, there are different names. And you're responsible to know up the number of sides for 10. That is a decagon. Now, if you notice, we can go ahead and assign a variable for the number of sides n, which means that anytime we're trying to come up with a polygon name after a 4-sided polygon, you'll begin just doing the n-gon. So 12 would be a different name as well, and 13 and so on and so forth. Now, once you understand number of sides and the polygon name, then you can find the interior angle measurement. And we'll be doing this throughout the school year, finding the interior angle measurements of a polygon. And it's given by a formula. If you take the number of sides and subtract 2, then multiply it by 180 and divide it by those same number of sides, then you'll be able to find out the interior angle measurement. Make sure that you box and star and highlight this formula because we will be using this quite often this year. Now that we went through the chart, I thought I'd show you what some of these pictures will look like so you can imagine them. And these are all regular polygons. So here we have a 3-sided, and I told you the interior measurement angles was 60 degrees for a triangle. Quadrilateral is 4-sided. A pentagon is 5, a hexagon 6, and so on and so forth. And so now you can see what a decagon will look like with 10 sides. Just a reminder, you do want to take the time out to draw pictures of all these regular polygons. Sorry that the picture is a little bit blurry, but go ahead and if you can't read it for some reason, it's in your textbooks as well. And these are the 2 theorems that are discussed within this section from the textbook. And it's really the 2 theorems that go hand in hand with when we talk about polygons. The first one is the polygon angle sum theorem. So make sure you write that down, of course. It's the sum of all measures of the angles of an n-gon is n minus 2 times 180. So on that chart, we divided it by n to know what each angle measurement would be. But if you just want to know if you added up all the angles in a polygon, what would the sum be? You would use this formula. So you wouldn't divide it by n. And then there's theorem 315, which is the polygon interior angle sum theorem, which tells us that all of the exterior angles, no matter what type of polygon it is going to always equal 360 degrees. So there's a small picture here where it shows you the 1, 2, 3, 4, and 5 are all on the outside of the polygon. They're called exterior angles. If you add all those up, it will always equal 360, no matter how many sides the polygon has. Here's a picture of that last theorem that we just discussed. So if you labeled each angle 1, 2, 3, 4, and 5, if you add up all the sides, 1, 2, 3, 4, and 5, that will all equal 360 degrees. And now here's a picture that summarizes everything we just discussed. If you look on the inside, well, first of all, these are all different types of polygons here. Here's a 3-sided, a 4-sided, and a 5-sided polygon. I want you to notice that we found the interior angles. So remember, the sum would be 180 for a triangle, but if we divided that number by n, we would find out that each interior angle would be 60 degrees. Then also, we want to look at all of the exterior angles. And if we add up 120 plus 120 plus 120, that will equal 360. I want you to also notice that if you put a little semicircle around, we have a straight angle here. So they're always going to be 180 degrees right there for straight angles. Here we have a square next to that, which is a 4-sided, a quadrilateral polygon. It also has all of the interior angles, which were going to be 90 degrees. And then if you add up all these 90 degrees on the outside, it's going to equal 360 degrees. And you can also see the straight angles. That's 180, 180, 180, and 180. And the last, let's look at the pentagon. This one has, if you look back at that chart that you copied on the first couple of slides, you'll notice that each interior angle is 108. You can take n minus 2, which would be 5 minus 2, then multiply that by 180 to find out, and then divided by n to find out that each interior angle is going to be 108. And then if you add up all of these 72s, they will also equal to 360, and those are all the exterior angles. And once again, 72 plus 108 is 180, 180, 180, 180, and 180. So on this slide, we discussed interior angles, exterior angles, and the fact that you have straight angles that will always add up to 180. Okay, now that we discussed the polygon angle sum theorem for interior and exterior, we can apply it to a problem where we're just talking about interior angles. Notice that we have angles A, B, C, D, and E, and they're within a polygon, and this polygon has 1, 2, 3, 4, 5 different sides. I'm going to erase those marks too, because that would note that each side is congruent and they're not congruent. So I just want you to know that this is a 5-sided polygon. So the first thing we need to do is figure out what if I took all these angles, angle A, B, C, D, and E, if I added those all up together, what would be the total angle sum inside the polygon? To do that, we'll need to use the formula n minus 2 multiplied by 180. And so that's to find out what all the angles are going to equal. We'll plug in 5 for the n since it's a 5-sided polygon, and we'll subtract 2. Then we'll multiply that by 180. If we do that, our answer is going to be 540 degrees. So that doesn't mean that each angle is 540 degrees. It means that if I add up all of the angles, it would equal 540 degrees. Now that I know what the total sum measurement is inside the polygon for angles, I can now go ahead and set up an equation to solve for the x value, and I can find out what each angle measures. Now, I'm not dividing it by n, remember, because I don't want to know what each angle is going to measure. Plus, the only time you divide it by n is if you have a regular polygon, and this is not a regular polygon. Let's go and add up all the sides. I will take 5x plus 2, 3x plus 5, 8x plus 8, 4x plus 15, and 5x plus 10. So this is for all angles A, B, C, D, and E. If I add all these up, I would get 25x plus 40. And I'll set that equal to my angle sum measurement since I know that's what they're all going to equal. Once I solve for x, I'll get x equals 20. Now that tells me what the x variable is, but if I said, okay, now tell me what the measurement is of angle A, you would take angle A, which is equal to 5x plus 2. You'd plug in 20 for x, so that's 5 times 20 plus 2. Angle A would then equal 102. 5 times 20 is 100, and then if we add 2 in, we would have 102. And for the rest of it, I would challenge you to try to figure out what the angle measurement of angle B, C, D, and E is by plugging in your x value. There's another example like this in your textbook if you like to practice one. And I would recommend that you rewatch the video if you had some difficulty and make sure you get all the information down because there was a lot of information in this video.